Good day, everyone. This is Smokeless Chimney. This is a high-level discussion on light sensor development. What we see here is the transmissometer used to measure smoke. It's a diagram I drew quite a while ago. Light source on the right side and a light sensor on the left side with smoke in the chimney in the center. We project a light source through the smoke and use a light sensor to determine what has changed in the light. This is a light sensor I'm currently using. It's a TSC 34725. It's a good sensor. It communicates with I²C. It has a couple of problems. One is there's an LED. It's yellow near the center. If you power this up, it will turn on that LED, and that doesn't work well with a transmissometer. We want to turn that off, and we do that by tying the ground and the LED pins together. So we're essentially grounding out the LED so that it doesn't turn on, and it only sees the light coming in from the light source of the transmissometer. This is the OPT4048, an XYZ color sensor. It does not have an onboard integrated LED. It appears you could put one on if you wanted to. However, on the previous sensor, it takes about a half hour to put a ground wire in. So this is attractive in that it doesn't have the integrated LED that you have to disable. There are other features and benefits with this, and we're going to compare and contrast them. This is the meat and potatoes where we compare the TCS 34725 that we're currently using to the Texas Instrument OPT 4048. The first sensor uses an RGB and a clear light, and this works very good. We found very good results using it as a transmissometer, but it's got the integrated LED. The OPT 4048 uses a Transmissometer XYZ, but it still produces color and lux. These are important things. When we get to the resolution, the TCS 34725 has a 16-bit, which is a range of 65,000 possible values, and that's on each of the four diodes. And that's been working quite well. We haven't really hit the top of that. And the diodes are great for bright light. When the beam is clear, we have bright light. It works very well there. The OPT 4048 has 20 bits, and that is more than 1 million possible values. That's a lot better than 65,000. So there's an element there where we could increase the resolution. The dynamic range, that's not critical to us because we're using about 300 lux, so somewhere between 100 and 1,000 lux, and these have more than enough range. So the spectral response is something we look at. We want IR blocking, and both sensors have IR rejection or IR blocking, and I actually get an IR number when I talk to the TCS 34725. I haven't found it useful, but it does give me a value for the infrared content. Ambient light rejection, in a transmissometer, we don't have much ambient light, so it's not really a big deal. Primary output, this is where things get complicated. We use the raw RGB clear values when we're projecting the light through smoke. We receive the raw RGB values on the TCS 34725. And we also calculate the lux and the corrected color temperature. And there's some debate on narrowband lights, if the lux is being calculated correctly, and therefore the corrected color temp is being calculated correctly. However, the sensor in the library produced these numbers. On the OPT 4048, they have calibrated CEI XYZ values for color, which is different than RGB, but they also provide the lux and the corrected color temperature. So I think it's giving us all the things we need. There may be some math in order to get the same values that we get with the TCS 34725. I²C speed, more than fast enough, 400 kilohertz for the our current sensor with up to 6 megahertz for the newer sensor. Power consumption is about 1/10. It's less than 1/10. It's significantly lower, so better for battery operation. And complexity. We have a relatively simple TCS 34725 that we have to disable the LED, and we have a new sensor that has more advanced features, but it's still supported well enough with libraries that I think we could use this one. They're costing around $10 each, and I can pick up the TCS 34725 for about $5. On the left, we have the XYZ coordinate system. On the right, we have the RGB color wheel. You can see that you can blend things together. You can determine any color based on the red, green, and blue diodes. With the XYZ, we're going to have to learn a little bit. However, I believe that from one unit to the next, if we use the XYZ system, we'll be able to compare and contrast between units or between transmissometers better. So if we get a light shift of, let's say, 10, it'll be more comparable when we use the XYZ system. This is all hypothetical. We got to go buy the sensor, get it implemented, get it working. The other thing is that the OPT 4048 appears to be better at temperature stability. In other words, giving the same light reading regardless of temperature. The transmissometer on a wood stove may start out really cold in the morning when you calibrate, and then rapidly gets up to 250-degree gases, which heats up the whole system, including the sensor. And the TCS 34725 is known to drift. We've been able to compensate for this, but it's a problem in that there's no integrated temperature sensor, and the sensor just tends to drift with a temperature increase. We think the OPT 4048 will be less of a temperature, or the light sensing value will be impacted by a temperature rise less. At least the data sheet says it will.
In the heart of the home where warmth is key, a secret hero works to keep the air free. No smoke, no fumes, just clean and bright. Our smokeless chimney shining with delight. Smokeless, smokeless, a wonder to see. Clear skies and fresh air for you and me. No soot, no grime, just a peaceful sight. Our smokeless chimney working through the night. The fan spin round with a gentle touch, adjusting airflow with a careful clutch. Temperatures checked and the data's fine. Our system's smart, always on our mind. Smokeless, smokeless, a wonder to see. Clear skies and fresh air for you and me. No soot, no grime, just a peaceful sight. Our smokeless chimney working through the night. ASMO's magic connects us with ease. Direct communication in perfect harmony and peace. F displays and sights guide our every move. A symphony of tech to keep our air improved. Smokeless, smokeless, a wonder to see. Clear skies and fresh air for you and me. soot, no grime, just a peaceful sight. Our smokeless chimney working through the night. A wonder to see. Clear skies and fresh air for you and me. No soot, no grime, just a peaceful sight. Our smokeless chimney working through the night.